In this video we're going to be looking at forming partial fractions, but first a reminder of how to add algebraic fractions. So if I just take three fractions, 4 over x plus 2 plus 3 over x plus 3 plus 2 over x plus 2 squared. When you add fractions, you obviously make a common denominator, and it's the same for algebraic fractions. And you need to choose the lowest common denominator. So here we've got x plus 2, x plus 3 and x plus 2 squared as our denominators. So the lowest common denominator is x plus 2 squared, x plus 3. Okay, so that's our denominator. The first one, we've just got the denominator of x plus 2, so we need to multiply the 4 by x plus 2 and x plus 3. The second one we need to multiply by x plus 2 squared, and then the third one we need to multiply by x plus 3. Okay, so we have 4 lots of x squared plus 5x plus 6x plus 3 lots of x squared plus 4x plus 4 and 2x plus 6 all over that same denominator, x plus 2 squared, x plus 3. Okay, so we need to combine those terms. Actually, let's just make that a little bit smaller. So we've got a bit more space. Okay, so we've got 4x squared plus 20x plus 24 plus 3x squared plus 12x plus 12 plus 2x plus 6 all over x plus 2 squared, x plus 3. It's important to always write your denominator because otherwise you've got incorrect algebra, which you could be penalised for. Okay, so lastly, just combine all the terms. Whoops, missed an x squared there. So we've got 4x squared and 3x squared, so 7x squared. 20x, 12x and 2x makes 34x altogether. And 24 plus 12 plus 6 is 42. Okay, so that's our answer. Just want to possibly come back to that a bit later. Okay, the reverse process of adding fractions is to form partial fractions. So this time we start with one expression. So let's say x plus 3 over x plus 1, x plus 2, and we want to separate it out into two partial fractions. This is useful in quite a lot of C4, particularly in integration and in the binomial expansions that you'll be meeting later in the course. So anyway, we start off by saying, okay, this is going to be identically equal to something over x plus 1, we'll call that a, and something else over x plus 2. So we know the denominator is x plus 1 times x plus 2, so in the partial fractions we'll have two fractions with each of those as denominators. So then what we need to do is to make the right-hand side have the same denominator as the left-hand side. So we're going to make that x plus 1, x plus 2 as well. And so we have a times x plus 2 and b times x plus 1. And those two expressions are identical. They've also got the same denominator, so that tells us that the numerators must be equal. So x plus 3 must be equal to a times x plus 2 plus b times x plus 1, and that must be true for any value of x, because that's how we've kind of set it up. We said it was always equal to. So what we can do then is choose any value of x we like, and I'm going to choose x equals minus 2 first of all. So on the left-hand side we've got minus 2 plus 3 equals a. Now x is minus 2, so that's going to be times 0, and b times minus 2 plus 1. Okay, so we've got 1 equals no a's and minus b. So that tells us that b is minus 1. Now the reason I chose x is minus 2 was to make that bracket with after the a 0. So the second obvious choice would be to make x equal to minus 1. So let's do that. So we've got minus 1 plus 3 is a times minus 1 plus 2, and this time b times 0. So we have 2 is equal to a. Okay, so that's all we need really. We've got our answer. So we now know our fraction, which was x plus 3 over x plus 1, x plus 2 must be equal to 2 over x plus 1 minus 1 over x plus 2. Okay, so we can make partial fractions when there are three factors in the denominator in the same way. So we just need a third thing that we need to find. So we're going to have a over x plus 1 plus b over 2x plus 1 plus c over x minus 2. Okay, so we do the same thing as before and make a common denominator. So we want the denominator to be the same as the left-hand side. And then we need to multiply each term by whatever wasn't in its original denominator. So a is going to be multiplied by 2x plus 1, x minus 2. b multiplied by x plus 1, x minus 2. And c by x plus 1, 2x plus 1. Okay. Right, so now we've got the denominators the same, so we can make the assumption that the numerators are the same. So we've got 5x squared plus 3x plus 4 equals a into 2x plus 1, x minus 2. Now, don't multiply out these factors at this stage. You'll see why in a minute. It's always best to keep things in algebraic fractions factorised as much as possible, and then hopefully something will simplify due to the factorising. So just write them out in full in their factorised form. Nearly got room for C there. Okay. Right, so then we take each bracket in turn and make it 0. So I'm going to start off with making this bracket 0, which will also make this bracket 0. So we're going to make x equal to 2. So if x is equal to 2, we've got 5 times 4 plus 3 times 2 plus 4 on the left-hand side. The a term has gone because it was multiplied by 0, so is the b term, so we're just left with c, which is going to be 3 multiplied by 2 lots of 2 plus 1 by 5. Okay, so we've got 20 plus 6 plus 4 equals 15c, and that's 30 equals 15c, so we know that c is equal to 2. Okay, let's make a bit of space here. So we've made one of the brackets equal to 0, so now let's make this one equal to 0. So that's, gosh, x plus 1, so that makes also this one equal to 0. So we're going to say that this time x is minus 1. So if x is minus 1, on the left-hand side we've got 5 minus 1 squared is 1, plus 3 lots of minus 1 plus 4. And that's going to be equal to a, times 2 lots of minus 1 is minus 2, plus 1, multiplied by minus 1 minus 2. Okay, so we've got 5 minus 3 plus 4 equals a times minus 1 times minus 3. So that gives us 6 equals 3a, so a is 2. Okay, so we've got 2 of our unknowns. So the last one we need to do is to make the remaining bracket equal to 0. So for that we need to make x is minus a half. So on the left-hand side, we've got 5 lots minus a half squared is a quarter, plus 3 lots of minus a half, plus 4. And that's going to be equal to, this time it's the b term that isn't 0, so b lots of minus a half plus 1, and minus a half minus 2. Okay, so we've got, I'm going to make all of this have a denominator of 4 because I've got 5 quarters there. And then I've got minus 3 halves, which is minus 6 quarters, and then 16 quarters. And over here I've got 3 times a half times minus 5 over 2. Okay. So, I think I made a little funny mark there. So we've got 15 quarters on the left-hand side is equal to b times minus 5/4. So b is minus 3. Okay, it's our third unknown. So it's always good to write the answer as well. So we know that, I'll just be a bit lazy and say that that fraction is equal to a, which was 2 over x plus 1, minus 3 over 2x plus 1, and then plus 2 over x minus 2. And obviously in an exam, a good way to check would be to use a common denominator and add them together and see if you get back to the beginning. Okay. So here we've got a repeated linear factor. What I mean by that, we've got an x minus 2 squared, so we've got x minus 2 times x minus 2. So it may be tempting just to write that as a over x plus 1 plus b over x minus 2 plus c over x minus 2. But hopefully you can see there's a problem with that, because if we just had two different numbers, b and c, that were over x minus 2, we could combine them into one, and that would mean that we hadn't really accounted for the fact that it was x minus 2 squared. Okay, if you think back to the beginning, we had this example. So this is the example we had before, and we had if you think of going from the left-hand side to the right-hand side, we had an x plus 2 and an x plus 2 squared in the left-hand side, and they combine just to give us an x plus 2 squared in the right-hand side. So if we're reversing that process, we need to allow for the fact that to form the x plus 2 squared in the denominator, it may be made up of an x plus 2 and an x plus 2 squared. So basically we just use that fact in setting up our partial fraction with a repeated linear factor. So in fact what we do is we set it up with a over x plus 1, b over x minus 2, and c over x minus 2 squared. Okay, let's just change my pen colour, but actually it's okay to have that in red to emphasise it. So we have, again, making a common denominator, so we want x plus 1 multiplied by x minus 2 squared for our common denominator. So a is going to be multiplied by x minus 2 squared. B is going to be multiplied by x plus 1, x minus 2. And our c, which is already has a denominator of x minus 2 squared, is just multiplied by x plus 1. Don't be tempted to miss this line out, especially when you're dealing with a slightly more complicated partial fraction, because it is important to check that your denominators are the same on the left and the right hand side, and I think that's a good way to sort of check that. So what we have now is, because the denominators are the same, so our numerators must be the same. So we've got a times x minus 2 squared plus b times x plus 1, x minus 2, and c times x plus 1. Okay, so let's make a little bit more space. Okay, so we'll do the same process as before initially. So we're going to first of all make the x minus 2 bracket equal to 0. So we'll say x is 2. So we've got 4 lots of 4 minus 3 lots of 2 plus 2 on the left-hand side. The x minus 2 bracket is now 0, so we've got, so that the a term goes and the b term goes, so we've just got c times 2 plus 1. Okay, so we've got 16 minus 6 plus 2 is equal to 3c, so that's 12 is equal to 3c, and c is equal to 4. Okay, so now we'll make the x plus 1 bracket equal to 0, so we've got x equals minus 1, so 4 lots of minus 1 squared, is 1, minus 3 lots of minus 1 plus 2, and the only term that remains now is the a term, because the x plus 1 bracket has disappeared from both the b and the c, so we've got minus 1 minus 2 squared times a. So that gives us 4 plus 3 plus 2 is equal to minus 3 squared is 9, so 9a. So 9 is equal to 9a, so a is equal to 1. Okay. Now, we've got a problem, a slight problem here, because how are we going to go about making finding what we've got A and we've got C, but we haven't got B. And there's no other way we can make a bracket equal to 0. So we need to use an alternative method. And the method I like to use is equating coefficients. It takes a bit of getting used to, but if we think about our two sides of the equation here, so we've got a left-hand side and our right-hand side, and they're equal. Then the number of x squareds in the left-hand side must be equal to the number of x squareds in the right-hand side. So I'm just going to equate the x squared terms on the left-hand side and the right-hand side. So I've got 4 x squareds on the left-hand side. If I was to multiply out this x minus 2 squared, I'd have an x squared term, so I've got ax squareds there. Similarly, if I multiplied out these two brackets, I would have b times x squared, and there's no x squared term attached to the c. So I know that 4 is equal to a plus b, so that tells me that b is 3, and that's a nice simple way of doing it. Okay, so the answer, which is what we want, wobble. Okay, so the answer to our fraction is 1 over x plus 1 plus 3 over x minus 2 plus 4 over x minus 2 squared. Okay, so remember, when dealing with a repeated root, you need to write x minus 2 and x minus 2 squared. Okay, so now we've got, what do I mean by a top-heavy example? What that means is where the top of the fraction is of an equal or higher order to the bottom one. So in this, what I mean by this one, the top fraction is a quadratic, so it's of order 2, and the bottom is also a quadratic of order 2. So if the degree of the polynomial of the numerator is equal or higher to the degree of the polynomial of the denominator, then we say it's top-heavy. Sorry about the scruffy writing there. Okay, so that's what top-heavy means, and there's a particular thing we need to do with that type of partial fraction. So what we need to do, first of all, is, before we start making it into partial fractions, is to divide through. So if we multiply out the numerator, we'll have x squared minus 2x minus 8, and we need to divide that into 2x squared plus 5. I'll leave a space because there's no x term there. So x squared into 2x squared goes twice. Multiply our quadratic on the left-hand side by 2, so we've got 2x squared minus 4x minus 16. Subtract those, we've got nothing minus 4x is 4x, and 5 minus 16 is 21. So the fraction that we started with, let's just call that f for fraction, is equal to 2 plus 4x plus 21 over x minus 4, x plus 2. And then we just do partial fractions on this bit. So on the 4x plus, so if we say 4x plus 21 over x minus 4, x plus 2 equals a over x minus 4 plus b over x plus 2. So I am going to miss out the line just because I'm running out of space. 4x plus 21 is a into x plus 2. I'm equating my numerators because it's a very simple one. I'm allowed to do that. Times b times x minus 4. So x equals minus 2. So we've got minus 8 plus 21 is minus 6 times b. So it's not very nice numbers this time, so b is minus 13 over 6, And if x is 4, then we've got 16 plus 21 is 6a. So a is 37 over 6. Okay, so then when we come to do our answer, so f, we've got to remember that 2. So 2 plus, the a was 37 over 6. I think I've written it round the wrong way. Sorry, let's change that to 37 over 6. So it's 37 over 6 lots of x minus 4. And then the b was minus 13 over 6, so minus 13 over 6 lots of x plus 2. Okay, so that's the answer to that one. So basically, straightforward partial fractions, you just write a letter over each of the factors. If you've got a repeated factor, you need to remember that thing of writing, if you've got x plus 1 squared, an x plus 1 term and an x plus 1 squared term. And if you've got a top-heavy fraction, you need to divide first, make a partial fraction of the piece that isn't the number on its own, but not to forget to put the number on its own into your answer as well. Okay.